Hey guys, my name is Sumit and welcome to my channel again. So today I'm going to solve LeetCode medium problem top k frequent elements. So this problem says that we are given a array which is called nums, and then we are given an integer k, and k represents the number of frequent elements that we want to return, and the answer can be in any order. So let's understand this problem. So for example, in this example, as you can see, the I mean the most frequent element is one, right? Because one is appearing three times in the array. Two is appearing like two times. So two is the second most frequent element, and three is appearing only one time. So three is like least frequent element, and we want top k frequent elements. So k represents k is two. So we will return only one and two as the answer, right? And same for this example, like we have only one element in the array, and we want only one frequent element, so the answer will be one only. So so basically what we have to do in this problem, we will have to create a hash map. So hash map will store the count of each element, like the number of times it's appearing in the array. So as you can see, one is appearing three times, so the key will be one, and the count will be like number of times it's appearing in the array, so which is three. Same way, like for two is appearing two times in the array, so I for key two it will be two, and three is appearing only one time. So for key three, count will be one. So that's how you have to create a hash map. Then after you create a hash map, what you have to do, you have to create a mean heap using priority queue. So priority queue, I mean mean heap means like you store the least frequent element, or the least frequent element and its root in this case. So for example, so what we have to do after creating hash map, we will have to iterate on the key of the hash map. Okay, not the count, I'm just saying the key of the hash map, and then check. First we will add that in the queue. Okay, so for example, when we add one, so our queue will look like this, and then I will check if the size of the queue is less than the k or not, because we don't want to have more elements than k, because any elements greater than, like more than k, will of no use to us, because they will be least frequent element. So so I added one, and then size of the key is less than k, so we are good to go. We go to next key. So we pick that, we add that key in the queue, and we check if the size of the queue is less than k or not, which is two. So it's fine. It's less than k, right? I mean less than or equal to k, right? So that is fine. But less than or equal to, it should be less than or equal to, not less than or equal to, that is fine. But here when we come to key 3, when we add that, then what happens, the size of the queue will be greater than the key, right, in this case. So we will pop the least frequent element. So we will pop the element from its root, so because root will be holding the least frequent element, right? So in priority queue, like so so basically some people might get confused, because I know if you are fresher, you're trying to visualize this, don't visualize it like this. So basically in queue, what happens, we add element at the end of the like at end, not at the first position. So then you might think, why am I adding two here? Why am I not adding two at, like after one? I mean to say, like, why am I not adding like this? You might visualize like this. So basically what is happening, like I said, priority queue will hold the least frequent elements, so it will reorder the elements internally. So when you add two, basically it will add, yeah, okay, you are adding at the end, but it will reorder its position to root position, because the count of this element in the queue will be uh, lesser in these two elements, right? In 1 and 2, between 1 and 2, 2 has the least count, so it will be at the root position. In the same way, when you add 3, basically you are adding 3 at the end, but it will reorder 3 to the root position, because 3 has the least frequent element, right? So that's what it's happening. And then after you pop 3, so our final queue will look like this. So and then we just have to create the final, final output array, and then we pop each element one by one from the queue, and then we put that in the array, and then we return the array. So that is simple. And since it can be in any order, so if you I will tell you later what I am trying what I want to say. So first create a hash map. I hash map. So count, sorry, integer, key will be of integer type, and count will also be of integer size. And then hm, and then new, and then hash map, right? Then what you have to do, you have to iterate on the input array. Okay, and then you put each element, I mean, you create a hash map basically. So I will check if that number is already there in the hash map or not. If it is not there, if that key is not there, so it's coming in that hash map for the first time. For example, let's say when you are at the first like on when you are at the 0th index of the array, 1 is appearing for the first time. So count of 1 when we are here, it will be 1, right? It's appearing only one time. So that's what I mean to say. So that time when it's appearing for the first time, we will just put the count as 1. Count as 1. Okay, key will be num, the which will be 1, and then count will be 1. And then else else it contains, I mean, that element is already there. I mean, for example, when we are at first index of this array, so that means 1 is already there because we already have placed this one. So 1 is already there. So now we will take the last count of the one which was 1, and then we will add the current, like we will add 1 in that current count to include the current occurrence. So now our count will become 2. So that's what I will do. So hm dot put, and then I will put num. I will get the last count of the key, and then I will add the 1 to include the current occurrence. Okay, so now my hash map is ready. Now what I have to do, I have to create a priority queue. Okay, so it will be holding integer type, name it as pq, and then new priority queue. So how do we want to store the element in the priority queue? We want to store the element in the priority queue based on the count of the element. Okay, so the count of whatever element which is least, that will be at the root position of the priority queue. So we will have to pass a custom what to say, comparator using lambda operation, and then we can do like this, hm dot get. So hm dot get a minus b will give the hm dot get. What does it return? It returns the count, right? So that's why I'm using hm dot get. Okay, and pass the two parameters. So these are two objects, and comparing two objects, hm dot get a minus hm dot get b. So this will store the elements in the decreasing order of the count of the key. Okay, decreasing, not decreasing order, I mean the increasing order, right? It will store elements, or it will in increasing order of count of key. Okay, once that is done, then what I will do, I will again iterate on the key set, I mean key of the hash map. So how do you do that? You can use call hm.keyset function. So keyset function will returns the key of the hash map. So which it will return only 1 2 3, and then you add one, like each key in the queue one by one. Okay, sorry. And then you check if the size of queue, pq dot size, is greater than k. If it is greater than k, then we will pop the element which is at the root position. So for example, what I mean to say, like for example, after adding 3, Our queue will look like this. But now for k is 2, right? We want only two frequent element. But here the size of PQ is 3. So it contains three frequent element. So three most frequent element, but I want only two. So I will have to discard one of these three frequent elements. So which element will you discard? Obviously you will return, sorry, you will discard only that element which has appeared least of the time, right? So which is 3, because 3 has appeared only one time, so you will discard 3 from the root position, and then our final queue will look like this, right? So that's what I did here. And then you create a final array, okay, and then new int, and then it will, the size of the array will be pq dot size. Okay, and then you just pop each element from the queue one by one, and then you just put in the array, and then you return the array, since it can be in any order. So for example, what I am trying to say, so for example, if we do like this, result dot length I plus plus, then result of I is equal to pq dot hold, right? And then you return result here, return result. So we will see how our output looks like first for this. So as you can see, in the example the output is as 1 2, but here like answer is like 2 1, but still it's getting accepted. Why? Because it says that we can return the answer in any order, and then obviously like in the queue, like we are sorry, we are popping 2 because 2 is least frequent element between 1 and 2, and then we are putting at the 0th index of the array, right? So that's why it's like this, 2 and 1. But if you want in like if you want if you want the answer in original order, you just have to iterate from the last index of the array. That's what you have to do. So for example, in spite of iterating from the first index, you just have to iterate from the last index of the array, and then I greater than equal to 0, and then I minus minus. And if you comment this out, then this should be fine. Now our output is like in the desired order. So anything is fine. You can put the answer in can be in any order. So you can write either in this way or you can write in this way. Anyway, it's fine. And time complexity of this problem will be O of k log k. Okay. So that is the solution. Let me try to submit it. So it's working fine now. Okay. So alright guys, thank you for visiting my channel. If you are new here on my channel, please give give a vote to this video if you like it, and please subscribe my channel, and please follow me on my social media. Thank you. Bye.